Welcome to the Martin Bailey Photography Podcast. It's April 10, 2017, and this is episode 568. Today I explain the effect that changing your subject distance and focal length has on the perspective of the visual elements in your photographs. This is often confused with a change in perspective due to your lens's focal length alone, but that really isn't the case. Let me explain why. I'm actually writing this post on request from my friends over at Craft and Vision. They asked me to do this last year, and I'm just getting to it now that the dust has settled after my winter tour season. I also shot the example photos that we'll reference on the park near my brother's house in the UK on Christmas Eve 2016. They aren't great photos, but I wanted a scene with two distinct elements in it, one close by and one far away, so that we could see the effect that I'm going to explain. People sometimes get confused when talking about this subject and end up talking about how changing the focal length changes the perspective, and it actually does not. The only time that your perspective changes is if you change the distance from your camera to the subject. If you also change your focal length to maintain the same subject size, you will see a dramatic change in the relationship between the foreground subjects and the elements in the background. If you simply put a camera on a tripod and without changing the distance to your subject, then shoot a series of images as you zoom in or out, you can crop away the excess image that is captured in the images that are wider focal lengths, and you'll see that the relationship between the main subject and the background will be exactly the same. The perspective itself does not change by changing the focal length alone. The reason this perspective will change in my example photos is because I moved closer to my main subject and zoomed out, changing my focal length to make the main subject appear to be the same size in each photograph. When you do this, the relationship between the subject and the background elements changes dramatically, as we'll see. Let's take a look at my example shots to explain. For these examples, I needed a nearby and a distant subject so that I could easily explain this theory. I grew up playing in this park on holidays and weekends and knew that I'd be able to find a tree to place in front of the power station in the distance. So let's work with this. My first image was shot at 105mm from a distance of approximately 100 meters or 330 feet. After making this first exposure, I made a mental note of where the tree was in the frame so that I could recreate that as I moved closer. I changed my 24 to 105mm lens from 105mm to 70mm, looking at the focal length markings on the barrel of the lens. Then I walked closer to the tree, checking the size of the tree in the frame until I got it approximately the same size as in my first photograph. This second image was shot at 70mm from a distance of approximately 70 meters, which is 230 feet. Notice how the tree is the same size, but the power station behind it has shrunk a little. I repeated the process, changing the focal length of my lens from 70 to 50mm and moved closer still to the tree until it was the same size in the frame again, and shot my third image at approximately 55 meters or 180 feet. Once again, see how much smaller the power station has become. For my final test image, I zoomed all the way out to 24mm and moved close enough for the tree to look the same size in the frame, and shot this from approximately 25 meters or 82 feet. To compare these four images on the blog, you can click on them to open the images in a viewer and then click the right or left side of the images to move back and forth. If you're not already at the blog, you can get to this post at mbp.ac/568. When you compare all four of these images, you'll see that the tree is pretty much the same size in each, but if you look at the apparent size of the power station in the background, you'll see that it changes dramatically as we get closer to the tree and zoom out to maintain the size of the tree. Let's move on to explain why this happens. As we change the focal length of our lenses, we change their field of view. This is how much of the world we're able to capture in our image, and it's directly linked to the focal length. On a full frame or 35mm sensor camera at 105mm, we can photograph horizontally 20 degrees of the world around us. At 70mm we get 30 degrees, at 50mm we get 40, and at 24mm 75% of the scene before us enters our lens. You can usually find the field of view for your lenses on the manufacturer's website, but I checked the field of view for each of my example photographs using a program called RAWDigger that allows me to dig into the EXIF data. Canon actually write the field of view for the focal length used in the EXIF data of each image, and that's really handy. I also went into Canon's map utility that comes with my GP-E2 device that I use to geotag my images, and using the scale on the map and a rule against my computer display, I calculated the shooting distances that I mentioned earlier. With these two pieces of information, we can easily chart out the relationship between the four example images, including our shooting data and the angle of view, as you can see in this diagram. To really explain this, we're going to have to get a little bit geeky. Believe me, I'm no mathematician. It was my worst subject at school and I hate numbers, except when it comes to something that I'm interested in, like business, computers, and photography. Then I do like to dig down a little. First of all, for my own sake, I wanted to make sure that I'm doing this right, and to do that, I first figured out how to calculate the size of the tree in the photograph. We know that pi is 3.14159, so if we divide 180 degrees, the widest field of view that we're ever likely to be using in photography, by 3.14159, we get 57. That means that we can calculate the size of an object by multiplying the distance by the field of view in degrees and dividing that by 57. Armed with this formula, we can calculate that at 105mm, when I first photographed the tree from a distance of approximately 100mm, the field of view captured in the photograph was about 35 meters at the distance of the tree. So that's 100 times 20, which is the field of view in degrees, divided by 57 equals 35 meters. In Adobe Illustrator, I resized the example images to 1000 pixels wide and used the measure tool to find that the tree was 440 pixels wide, so it's taking up 44% of the field of view. So we can multiply 35 by 0.44 to learn that the tree is approximately 15.4 meters across at its widest point. That sounds about right. If we take the widest focal length of 24 millimeters and do the calculation, we get roughly the same answer. At 24 millimeters, the field of view is 75 degrees, and I photographed the tree from around 25 meters. So 25 multiplied by 75 divided by 57 times 0.44 equals 14.4 meters. There's a small variance, but I'm getting my actual shooting distance from my GPS information and measuring it with a very small rule against the computer screen, so there's room for error there. There may also be something going on as we focus the lens, so I'm not too concerned about this variance. It's close enough to prove to me, at least, that my math isn't too cranky. We can also mathematically understand why the power station gets smaller in relation to the tree, starting by doing the same calculations. Measuring out the distance from where I was when I took these photos, we're about 3,500 meters from the power station, and it takes up approximately 37% of the field of view in the 105mm focal length photograph. So 3,500 multiplied by 20 divided by 57 equals 1,228. Multiply that by 0.37, and the power station is about 454 meters wide from this angle. In the 24mm photograph, the power station takes up about 10% of the field of view, and we've moved 75 meters closer to the subject, so 3,425 times 75 divided by 57 times 0.1, which comes to 450 meters. Again, there's a very slight variance, but based on this, we can see that we are able to approximately calculate the size of the objects in the frame based on the distance to the objects and the field of view of our lens at any given focal length. To understand why distant objects are smaller in wider focal length images, let's do one last pair of calculations and find the width of our slice of world captured at the distance of the power station, kind of as a checksum. We actually got these numbers as part of our previous calculations, but to recap, we know that the power station is approximately 3,500 meters away in our 105mm photo, which has a field of view of 20 degrees. At 100 meters, where the tree is, this captures 35 meters of the scene, but if we extend this out to where the power station is, we're capturing 1,228 meters of the world. At 25 meters with a focal length of 24mm, we're capturing 33 meters of the world, but at 3,425 meters where the power station is, that captures a 4,500 meter wide scene. So an object which is approximately 450mm wide is going to take up 10% of a 24mm image, as opposed to 37% of a 105mm photograph. We know that we maintained the tree size at 44%, so this is our proof of why things get smaller as they get further away. Not being very good at maths, after spending most of the day working on these formula, you can imagine how happy I was when I entered my calculations into an Excel spreadsheet and calculated the size of the tree and the power station based on the field of view and distance alone, and then calculated that the percentage of the width that the power station would take in my images was exactly the same as that which I'd calculated by measuring the pixels in Adobe Illustrator. In practical use, we simply need to remember the following sentence. As we widen our focal length and move closer to our main subject, the background elements in our scene will appear smaller. That's it. I know this is somewhat obvious, and many of you will look at this alone and think, I knew that, and that's great. But I hope now you'll have a better understanding of why this happens, and now I understand it better than I did this morning when I sat down to think about the math. Let's look at a few more photos from the field, not shot to illustrate this point per se, but they will help to get a better understanding of how different our images can be just by thinking about the distance to subject and focal length. Here's a photo of a tree in front of a sand dune in Namibia, which I shot from 85 meters or 280 feet from the tree. Again, I know this because I geotagged my images and checked on Google Maps. My focal length for this was 80mm, but I cropped in a little along the top, so it's probably the equivalent of 90mm. The next image was part of a series of images that I shot vertically to stitch together as a panorama, but it didn't work because the dune looked tiny in relation to the tree. In all honesty, I don't know why I proceeded to shoot the series, but it helps to illustrate this point, so all is good. I actually shot this from around 30 meters, about 100 feet away from the tree. Because I've gone to portrait or vertical orientation with the camera for this photo, we automatically get more foreground and sky, so it's not a straight comparison, but you'll surely be able to appreciate how going a little bit wider and moving closer to the subject has shrunk the apparent size of the background. Knowing that the final image is what I wanted, I actually exposed the next image before the others from around 75 meters or 250 feet away from the tree with a focal length of 165mm. I think you'll appreciate that the background looks very different in the long focal length shot from a distance compared to the shorter focal length shot closer to the tree, even though the dune starts pretty close behind the tree. But because the sand dune is so large, it quickly recedes into the distance and starts to shrink in relationship to the tree very quickly. Finally, here's one last image that I made as we walked away from this sand dune. I shot this at a distance of 1.3 kilometers or 4,400 feet with a focal length of 200mm. Obviously now the tree is much smaller in the frame from this distance, but I wanted you to think about the difference between how the tree looks in this shot compared to the first two photographs of this tree and the dune above. In all three images you can see the tree with the sand dune from top to bottom. The apparent size of the tree compared to the sand dune is portrayed totally differently simply by changing the focal length and distance to the tree from the camera. One other thing that I'd like to mention is that you'll often hear people talking about zooming with your feet, just as I did to get closer to this sand dune. Zoom with your feet is one of those mantras that people latch onto and use for a number of reasons. I'm not going to go into details on my theories here, but I imagine that part of the reason for the popularity of this phrase is because people need to protect their egos, and basically they're backing up their buying decisions, whether to buy or sometimes not to buy a certain piece of gear. Worse still, sometimes people are probably just regurgitating a phrase that someone who should know better said in a confident tone. Personally, when I'm photographing wild animals or photographing a valley from a cliff edge, I prefer not to walk forwards. In a situation when you can move forwards, you need to be making your decision to do so based on how the focal length, or more specifically the field of view, and the distance to your subject and scene will affect the look of your photograph. You definitely don't want to be zooming with your feet just because someone etched the phrase "zoom with your feet" into your brain. I hope that what we've covered today will help you to make an educated decision for yourself as to whether it's better to move closer to your subject or shoot it from further away while zooming with your lens, not your feet. Thanks very much for listening today. If you enjoy this podcast, please share a link with your friends. Subscribe in iTunes or your favorite podcast program to ensure uninterrupted delivery. If you have a moment to rate this podcast or leave us a review in iTunes, that helps to keep us relevant in the huge number of podcasts out there now. You can find me on Google+, Twitter, Instagram and Facebook, etc. And links to everything that I'm up to are at martinbaileyphotography.com, so do drop by and take a look. I'll be back next week with another episode. But in the meantime, you take care and have a great week, whatever you're doing. Bye bye.